My name is Doug Stevenson. I am a developer advocate with the Firebase team at Google. I do a lot of stuff with Firebase. I'm nuts for Firebase. I'm kind of paid to be nuts for Firebase, though, so take everything I say about Firebase with a grain of salt. No, actually, it's very good. What they don't pay me to talk about is Android things. I got a hold of a test board a while back, and I started to experiment with it. I have no experience with hardware. I am bad at hardware. But I like Android things because I'm a longtime Android developer. So I've been doing Android since, 8 years ago. So the HTC G1, the very first Android phone, that was my phone, and that's how I cut my teeth on Android development. So I have all these years of Android experience. So I thought, oh, a new Android thing, literally a new Android thing to play with. So I got a hold of one of these. This is what the Android things team have been giving out to people. It's a Pico IMX7 board. It's for development purposes. It's not an actual, you wouldn't ship this to a customer as an IoT thing. It has Wi-Fi built in. It has pins for touchscreen. It has a camera input. It has audio, USB. It's basically a little computer, right? It's kind of like a Raspberry Pi. And this can run Android. You can flash a version of Android things to it. Along with that came this rainbow hat peripheral. So this actually sits on top of the other board. It connects up to the 40 extension pins, and it gives you a bunch of peripherals that you can play with. So you've got 3 buttons, 3 LEDs, multicolor LED, temperature and pressure sensor, a buzzer that you can use to make sounds, a segment display, and there's even more pins there on the left-hand side. So you can hook up even more peripherals to it using a variety of protocols. So I got a hold of this. I'm like, what do I do? What can I build with this? And so, you do goofy things like flash LEDs and then make the screen say something, right? I mean, it's basically an Android device. And when you have the touchscreen on, it's kind of like a busted out phone. And I'll show you a picture of that later. But if you're doing I/O with various different peripherals, and again, this is scary to me because I'm not a hardware guy, you have something called GPIO, which is basically Boolean state on and off. So buttons and LEDs communicate over GPIO. I've got something called pulse width modulation. So if you're doing audio, you typically transmit audio over a PWM type connection. And everything else I'm about to say, the other 4 types of connections, are beyond me. I don't know anything about. There's probably one other person, maybe in this room, who knows more than me. Definitely another speaker will know more than me. But you have integrated circuits for doing a serial bus, and you identify the different items on the bus through software. There's also sensors. You can do things like sensors and displays and advanced peripherals. I've never worked with this before. There's also a sound version of that. So if you're doing audio transmissions over with PCM, you can use this protocol to communicate with devices. There's also a serial peripheral interface, which is kind of like a bus you'd find on a regular computer. And there's also UART for doing things like GPS and printers and RFID readers, things that are going to send you asynchronous signals over time. It's not just like a back and forth kind of thing. You're just receiving transmissions or signals from things. So all that said, if you have to code to these low-level interfaces, you're in for not a very good experience, in my opinion. But that rainbow hat little peripheral thing comes with all these drivers. So if you use these drivers in your app, you're basically coding to a regular API that's easy to consume and easy to digest. So go look for items that have Android things drivers, and all this is open source. These are specific to the rainbow hat, the things that are on the rainbow hat. So if you're the kind of person who likes to go deep into the hardware, maybe you're more comfortable writing drivers. I'm more of an applications guy. I'm a software guy, so I'm more comfortable consuming these APIs rather than building them. So when the board is all set up, it looks like this. This is normally what my desk looks like when I'm playing around with it. So you can see there's the Wi-Fi antenna sticking out. There's a camera on the ribbon cable off to the left, and there's the touchscreen. And the touchscreen is just like a regular old touchscreen. But if you're building your own hardware, you might have something like this. Now, this makes me sweat. I don't I know what I'm doing with the soldering pin, but I don't do it very often, and I don't know how to assemble things. But that said, all those little pins on the hat give you the interfaces to those all those different ways of communicating with devices. So if this is for you, that's great. Go nuts. I'm a software guy, so I'm going to stick to building prototypes with test boards. So Android Things is Google's platform for doing IoT development. So IoT, what's IoT? Internet of Things. That's pretty straightforward. You have all these things. They're connected to the internet, right? But how do you get these things to talk to each other? If you have all these things, presumably they're going to have to communicate or share data somehow. That's kind of the implication. IoT wouldn't be the I in the IoT wouldn't be there if these devices weren't talking to each other. And presumably, for devices that don't even have like, you know, a UI or a screen or, you know, strong ways to interact with it, you might have a mobile app there to control and direct and monitor what's going on. And again, the implication here is the app is talking with all the things. Now, this is great if all these devices are in the same room. Maybe they could use Bluetooth or something. But fact of the matter is these devices may not be anywhere near each other. And so if the understanding is they're connected to the internet somehow via Ethernet or Wi-Fi, there should be a back-end service that they all communicate through. And that's what I wanted to use Firebase for. I figured Firebase is a great way to centralize all the communications between all your devices. Now, how does this work practically speaking? Well, that's what I'm going to show you, something I built that actually uses Firebase as the backend for an Android Things project. So for those of you who are not familiar, Firebase is Google's mobile application development platform. Some people have called it a backend as a service, which is only half correct. There's a lot of components in Firebase that actually just help you understand how your app is performing. So like analytics and performance. Some things that help your app grow, like notifications and invitations and things like that. Right now, Firebase sits at 20 top-level features or products. Not all of these are supported by Android Things, but the ones that you would use to actually build out an Android Things project are there. So you have real-time database, cloud Firestore, cloud messaging, Firebase Authentication, cloud storage, performance monitoring if you want to see how your thing is actually performing, crash reporting, actually very helpful, remote config, and cloud messaging. Now, I didn't use all of these. I used a bunch of them. The ones in green are the ones that are known to be compatible. And I think Crashalytics maybe. I don't know yet. It's relatively new in the sort of pantheon of Firebase stuff. But the idea is that Crashalytics would eventually supersede crash reporting. Now, there's one very special feature up here that you don't actually integrate into your app. It's sort of a back-end thing. It's called Cloud Functions for Firebase. So Cloud Functions is part of the Google Cloud Platform. It itself is not a Firebase product, it's a cloud product, but Firebase adds a bunch of things on top of it. So at its core, Cloud Functions gives you a way to write code that responds to events that occur within your project. It's serverless. I don't know if you know that word. It's been very, very hot lately. It's serverless programming in that all you do is write and deploy code. You don't manage a server, you don't maintain a server, you never log into a server, you don't even know how many servers are running your code. You just know that it scales up or down to meet the demand. So this is entirely back-end stuff. And this is kind of the key component that can make IoT projects work really well. Oh, and by the way, if it's not clear, right now we support JavaScript and any language that compiles to JavaScript. So TypeScript is my favorite. You could use Kotlin if you want. I think the experience for TypeScript is very good. It runs in a Node.js environment, which a lot of you already know. And for HTTP type functions, you can use Express.js. So these are the components I use to build my project. And I'll say a little bit about them. Cloud Firestore is a lot like real-time database. They're both NoSQL type databases, meaning you don't have like a firm structure like you do in a SQL world. You have a very loose structure. You structure your data according to the queries that you expect to perform. Firebase Authentication is for login. So if you want to get users identified and logged into your app, this is the best thing to use. Cloud storage is basically file storage, so you're sending up blobs of binary data. And the most common use case for most apps is user-generated content, such as pictures and movies and audio, things like that. Things that are too big to fit in a database, that really don't belong in a database, but that need to be also scaled, like cloud storage scales to like petabytes. So put as much data as you want in there. Cloud messaging is for push notifications. So if you're trying to send notifications to devices, you use FCM for that. Crash reporting is self-explanatory, and also, of course, Cloud Functions. So what did I build? I built a doorbell. And you might be wondering, why would you build a doorbell? Like, this is very elegant and simple, and it works really well, and there's millions of them in the world. Like, every home on the planet has a doorbell, right? Why do you need to build another doorbell? Well, I live in Silicon Valley. I'm going to disrupt the doorbell industry. Let's just say that. That's my plan. Now, I don't know if there's a doorbell industry, but I know there's a lot of doorbells out there that need to be replaced. So my plan is to build a doorbell, not just any doorbell, a video doorbell. So I want this one to take a picture and send it to the app. So what it does at a very high level is someone pushes the doorbell. It will take a picture of you. So we'll use the camera attached to the thing to take a picture. That picture will get transmitted to the app, so presumably the owner of the home will have the app, and it'll get notified, and they'll see a picture and say, well, do you want to let this person in? Based on their response there, it will unlock the door. And I hope your door is protected by something other than a rusty padlock. I like this image. It's not very practical, but the idea is you'd have like a mechanical lock that's controlled digitally, right? That the IoT device would actually like say, you're either on, you're locked, or you're off, you're unlocked. So that's how it works from a user's point of view. From a system point of view, it's quite different. There's a lot of stuff going on here. And I won't even try to unpack this all at once. I'll go through it step by step, but what happens from the moment you press the doorbell to the time that the user gets or the homeowner gets the notification back to unlocking the door. So let's wipe out everything and start with just capturing a picture. So how do you capture a picture? It's pretty straightforward. Since it's an Android device, you can use the Camera 2 API. This is very, very well known, not terribly well documented, but there's really good sample code for that. So I just yanked the sample code and pulled it into my app. And of course, it all compiles because it's all just Android. But I ran into some problems. In the developer preview 0.5 of Android things, texture view is not supported. And the preview that it will show you on screen is blasted to a texture view. So I had to figure out a way around that. Basically, I ported it to use surface view. Surface view is a much simpler version of texture view. They both do the same thing, which is blast lots of frames of arbitrary graphics into a dedicated window. So porting from texture view to surface view was not exactly straightforward. It took some effort, but it's definitely doable. Then I found out the camera that was on my device doesn't support autofocus. So I had to actually remove the code that was depending on autofocus. So if you look at the state machine for how a camera works, there's different states it has to go through, and one of them is waiting for autofocus to settle. Now, in a perfect world, the sample code would check to see if the device has autofocus and only demand it if it were there. So I just ripped that code out. It works okay. Then I discovered in developer preview 0.6 of Android things, texture view is supported again, so I kind of felt like an idiot for converting it all to surface view. And I'm like, okay, well, that's great. You can enable hardware acceleration on the activity that's going to display it, and it does work, but it's slow. And that's slow because there's no GPU on an Android things device. So you've got to keep them cheap, right? They're supposed to be small and cheap. So I ported everything back to Surface View. Surface View actually runs much faster. So anyway, there's a little bit of a journey there, and it has nothing to do with Firebase. It has more to do with managing the Camera 2 APIs when you're working with Android things, at least 0.6 right now. So that's capturing the picture. Now what I want to do here is upload this picture to cloud storage. So as I mentioned before, cloud storage is just binary storage, right? So we're going to send it up there, and somehow that will make things work, right? Well, how do we upload, right? Pretty straightforward code. This is Kotlin. Kotlin because Kotlin, right? Everyone does Kotlin these days. So what I'm going to do is just format a date. And for those of you taking pictures, I will put all the slides online later, so don't feel like you have to take pictures of every slide. So I'm going to format a date, standard simple date format stuff. I'm going to build a string to this. This is going to be a path in cloud storage for that image. Hopefully it'll be unique based on the date. And then I'm going to use a Firebase storage client-side API to get a reference to that. So this reference object, this storage reference object, all it is a pointer within cloud storage. And what I'm going to do, take that ref and just call put file. And that's it. That's all you have to do with cloud storage. So the beautiful part of this client SDK is it manages all of the protocol, all of the everything. It manages retries. It manages resume in case the connection gets broken. It's very, very powerful. Again, one line of code gets you automatic and robust file storage. So after that, you can go to the Firebase console, and this is what it looks like. So this is basically a view of my cloud storage bucket from the Firebase console. You can see all the different rings I have in there so far. And I apologize. The image there on the right is just the picture of my ceiling at home. I didn't want to put it at me because I don't like to take pictures of myself. But anyway, you can see how all the rings. I'm calling them rings. That's it's a picture, but I'm going to call it a ring. So you can see what they look like. So what happens after cloud storage? Well, we still need to notify the app that it's there. Well, how do you do that, right? Do we need some sort of channel of communication? Well, it turns out the easiest way to do this, at least in my opinion, is to use Cloud Functions. And what you can do is use Cloud Functions to write a storage trigger. So you can write code. Again, Cloud Functions allows you to write code that responds to events in your Firebase project. The event here is actually a cloud storage upload. You can write trigger code to respond to that. And then I can turn around and write that information to Cloud Firestore as more of like a database-oriented view of the ring rather than just some file in storage. So now I'm switching gears. This is TypeScript, and it's running in Cloud Functions. We're no longer in Kotlin land, though it does look very similar to Kotlin. So what we can do here is use the Functions SDK to define a trigger. So what we're doing here is saying, I want my trigger to be on my storage bucket. It's going to look at objects that change. So this is like a kind of a fluent language of describing how I want my Cloud Function to work. And then I'll pass it a reference to the actual implementation of the function. So it's just _on ring. So The function here, and I love TypeScript so much better than JavaScript because you actually have types. You actually see what's coming into this. So this function is going to receive an event object, and that event object is genericized. And what this is saying is this is an event that has an object metadata thing inside of it. That object metadata object describes the file that was uploaded, and then I'm going to return a promise. And if you're not familiar with JavaScript or TypeScript, promises are kind of like tasks. If you're familiar with Play Services or Firebase, it's async programming. So what I'm going to do is pull the ID out of the path name so that formatted date now becomes the ID, the unique ID of this thing. I'm going to pull its path name out of the object so that inside the object metadata object I can get the path of the file. And then I can build a ring object, and that ring object will contain properties of everything I just created. And then what I'm going to do is go into Firestore and say, hey, Firestore, I'm interested in storing this document. I'm interested in creating a document in a collection called rings. And I'll show you what that looks like. So in Firestore, this is the Firebase console looking at my Firestore database. So interpreting this from left to right. On left, we have all of our collections, and there's just one collection called rings. Then in the middle column, we have all the documents. So these documents are listed by their unique ID, which is just the date, the formatted date. And on the right, we have the properties of that document. So you can see that it wrote the date, the ID, and the image path in there. So this is all well and good. Now we have something in a database that records the ring, the ring of the doorbell. What do we do there? We're still not even at the device. All we've done here is just, we've written something to the database. Where do we go from here? Well, the cloud function can also use FCM or cloud messaging to send a notification to that device to wake it up and say, hey, someone's at the door. Build a UI, load the data. This monitor went out, but that one didn't. Interesting. OK, so what does that code look like? It's pretty straightforward. We're going to build an FCM payload. This payload describes the notification that the device is going to receive. There's two parts to it. The notification part, which is actually something that will appear in the system tray, the notification curtain. And there's a data payload as well, and that's more of like the raw data that I'm trying to send. And all I'm really trying to send is the ID of the ring. There's one thing in particular I want you to pay attention to, and this click action property is itself, it looks kind of Android-y, kind of Java-y. Well, it's actually an activity action. So in my Android app, I have an action defined with this string. So that lets FCM know when I click the notification, it will automatically launch my activity. Now, I don't have to write any code to build this notification. It's great, right? It's going to do all that for me. And it's going to deliver the data payload to that activity. So all I do is say, hey, FCM. Oh, I went too fast. So all I do is say, hey, FCM, send that message to a topic. Oh, I didn't do an animation of that last one. I feel so terrible. Anyway, the bottom line there. I meant to highlight that bottom line. That bottom line is just saying, hey, FCM, send this data payload to a topic. And the way topic messaging works is it goes to all the devices that are subscribed to that topic. So I'll show you what that looks like later. But we have this topic called rings, and all the devices in my project that are subscribed to rings will receive this notification with the payload. OK, now I'll go through it again. OK, so we've done two things. We've written to Cloud Firestore, and we've sent a notification to the device. So let's see what it looks like on the device side to handle that notification. Because I sent a message with two parts, there's a notification payload and a data payload, there's a decision that needs to be made. And you don't have to write this code. FCM is making this decision for you. If your app is in the background, meaning there's no visible activity, it'll display the notification in the tray. And then what happens is when you click the notification, it'll launch the activity that you want, send the ring ID to it, and you do what you build your UI there. If the application is in the foreground, meaning it has a visible activity, it's actually going to invoke a service, and that service has to subclass Firebase messaging service, and there's a method in there that will get called that will receive your notification and all the payload, and then you can use that to launch the activity. So you just do a start activity or whatever it is that you want to do. So either way, you're going to get to the same activity. The path to get there from the user's perspective is a little bit different, depending on whether it's in the foreground or background. OK. So in my app, so this is on the device side now, this is in the the phone side, not on the IoT side. So what we have here is a service. It subclasses Firebase Instance ID service. And the only thing that is important here is the fact that I'm subscribing to that topic. The only reason why I'm using this IID service is because this is a notification that FCM gives me that it's now ready to do messaging. So I can't really call this method before I get an IID token, basically. I'm not interested in the token right now. I'm interested in just subscribing to the rings topic. And to handle that message, so when the message is received, and this is background again, so this is, boy, my monitor keeps cutting out. Oh, there we go. So what happens is there's a subclass of Firebase messaging service. On message received, it's going to get called with a message object. And then what we're going to do is pull the ring ID out of there. Remember, there's that data payload with the ring ID. I'm going to pull that out of there. I'm going to build an intent of the activity I want to launch, stick it in an extra, and then start that activity. And there's not much to it, right? We're just proxying that message into what appears to be an activity launch. Then inside the activity that gets launched, all we do is pull out the intent extras, look for the ring ID. Now, I'll remind you, this is what the document looks like. So what this activity wants to do, it needs to get a hold of that image path. It needs to display that image. So what we're going to do is reach into Firestore, pull out this document, and use it to display. So this is what the UI looks like. And I'm sure all your guests don't just show up looking like they had a professional headshot. This is not coming from an actual IoT device. This is just my professional headshot and 2 tiny little buttons that I need to increase the size of. So that's what I want to build. Now, the owner's going to push yes or no, right? Let him in or not. So how do we need to go round trip. We need to go back to the device so it can make a decision about what to show or what to do. So the first thing we're going to do is read the document out of Firestore and download that picture. So again, we're reading from Firestore. We're finding that document. The ring ID will let me build a path to find that document. And then that document will contain the image path to let me display my UI. So the way that works is pretty simple. Now we're back in Kotlin land. We've left TypeScript land. We're on the device now. What I'm going to do is use the Firestore SDK to reach into the collection called rings and then reach into the document with that ring ID. Now I'll just get that document. Pretty straightforward. It returns a task that I can listen to for results, and it's going to deliver me a data snapshot, actually a document snapshot. And then we're going to reach into that document snapshot and tell it, I actually want a ring object. I don't want the snapshot. I'd rather have a ring object. And so it's actually smart enough to do object mapping. So it takes those 3 properties, ID, the path name, and the date, and will automatically use getters and setters on that ring object to populate something. So it's super convenient. Once I have that ring object in hand, I can reach into its image path. So that image path property, well, it's a Kotlin property, which maps to a getter in Java. But I can use that to build a reference to storage. So I'm using Firebase Storage SDK to get a reference. Now, a reference isn't an image yet. It's just a reference. It's just a pointer into storage. Then we can use Glide to load that. Who here's used Glide on Android? Okay, a handful of people. So what Glide will do is it's very, very smart image loading and displaying tool. So what it'll do is load the image and display it all without blocking your app or you having to write any more code. But for those of you who are familiar with Glide, like, how does it know how to use a storage reference? We're passing a storage reference directly to it. Normally, you pass a URL. It'll download from the URL and then display that. But this isn't a URL. It's a reference. So how does it know what to do with this? Well, it turns out there's a very handy component called FirebaseUI. And FirebaseUI gives you some tools to help it to make it easy to pull data out of Firebase and display them in your app. So here we're defining a Glide module. So that annotation up there is telling the Glide annotation processor, I'm important. Load me at startup. So this thing will get invoked when your app starts up, and Glide will say, OK, look, well, actually, it's not when you start up. It's when Glide is first invoked. And what it'll do is give you a chance to register a handler for storage references. So what this line of code is saying, when you encounter a storage reference type object, use Firebase Image Loader Factory. Use an instance of that to actually load, download, cache, and display the image. So this one line of code is actually doing a tremendous amount of work for you that you would otherwise have to do by yourself. So Firebase UI, totally convenient for this. You should be using it if you're not. So where are we at? We need to round trip back to the IoT device. So what we're going to do is we're going to write an answer back into Cloud's Firestore. So that document with the 3 properties, I want to write back into it the disposition from the homeowner, right? Did they say yes or no? It's just a Boolean, so we want to write that Boolean back in there. So in the app, we're going to get that disposition somehow, and then we're going to call update on that ring reference. And that ring reference is, again, that document reference object that points to the location in Firestore. We're going to give it 2 items of data. We're going to give it the UID. I like it for auditing purposes. I'm not using it, but I want to store the UID of the user who authorized this, and I also want to store the disposition, which is the Boolean. Now, the net result of this is, you notice there's a dot there. There's answer.uid and answer.disposition. This is syntax that says I'm actually creating an object with its own properties within the document, and I'll show you what that looks like. So in Firestore, after this completes, you'll have a new section here. You'll have an answer object, and the disposition and the UID will be in there on top of what, well, not literally on top, but in addition to the properties we had there before. Now, where do we go with this? Like, the device still doesn't know that this has happened. We need to do something. So Cloud Functions comes in handy again here. So what we can do is write another Cloud Function that triggers in response to this update. Again, this is automatic. You're not telling it. You're not forcing it. It's just happening in response. This is very serverless programming. And then that Cloud Function is going to turn around and use Cloud Messaging to notify the IoT device. So now we're back in TypeScript world. We're back in Cloud Functions. So change gears out of Kotlin back into TypeScript with me. So what we're going to do is use the function SDK to say, I want to create a Firestore trigger, not a storage trigger, a Firestore trigger. And the document I'm interested in is described by this pattern. And you'll see that we know that there's a collection called rings, but we don't know, like the function doesn't know the ID. So we're just saying a wildcard here. We're going to say any document here that matches this pattern, I want to be notified when it's updated. And again, this is only updates. This is not creates or deletes. So I'm going to pass it a function, and that function takes an event, which is a delta document snapshot. The delta document snapshot is a description of the thing that changed. And again, we have to return a promise to indicate when we're done. So what we're going to do is reach into that wildcard, that little curly brace thing. We're going to reach into it and grab the ring ID. That's just the way to get the ring ID. We're going to get the previous version of the document and the current version of the document. This is how we know what changed, right? And what we were specifically interested in is the change that added the answer. We want to know what the answer was. So we're going to look and see, is this an update that we're actually interested in? So we'll look at the previous document. If it had an answer, we're going to bail. We don't care anymore. We already dealt with this. If the current ring doesn't have an answer, meaning they wrote something that wasn't an answer, well, also, I don't care about this. I'm going to bail. So this is protecting me against updates I don't want. So if someone updated the date or someone updated the image path, my update trigger would run, but it would bail early, saying, this isn't an update I'm interested in. We're only interested in the one that created the answer. So this goes on. What we're going to do is, again, create another FCM payload. We're going to stuff the disposition and the ring ID in there. And then we're just going to use FCM again to send to a new topic. And the old topic was rings. This is a different topic, answers. So the IoT device, the doorbell, and perhaps any of the other apps that are in this project could all be listening to this topic to know exactly when someone was let into the house. And again, it's just a few lines of code. You're like, you're proxying all kinds of data around. You're making queries. You're doing all kinds of fun stuff. There's a lot going on here, but it's abstracted away by what is very few lines of code, I think. So what we've done is we've written a Cloud Function that responds to the Cloud Firestore trigger. It invokes Cloud Messaging, and then we're going to notify the device, just like in the same way that the app was notified. So we have another service here. If you're having deja vu, this is because this service on the IoT side exactly matches the one on the app side, except the only thing that's different here is we have an answers. We're listening to the answers topic instead of the rings topic. Of course, the doorbell doesn't care about rings. It's the one doing the ringing. It doesn't need to be notified of that. Where this one just wants to know about answers. So again, handling a message looks very similar to handling a message on the app side. We're going to subclass Firebase messaging service. We're going to have our onMessageReceive method called with a remote message object. And we're going to pull the disposition out of there. FCM payloads are all strings. There's no strongly typed data, so we have to parse that into a Boolean. And then again, we're going to launch an activity with the disposition, that true or false, and start the activity. And this activity is going to be the thing that actually presents something to users saying, hey, come in, and it's probably going to unlock the door or whatever it needs to do. Now, I didn't actually have a lock on mine. I had a screen saying, hey, welcome, or go away, we don't like you. That's as far as I got. I need to find an actual locked. But the thing is, it's so simple. It's basically GPIO. It's Boolean. It's either on, locked, or off, unlocked. I mean, that's all there is to it. It couldn't be any easier. So that's the entire system diagram. So we have a lot of flow of data going through here. And I'll point out that Cloud Functions sits squarely in the middle of this, like geographically right in the middle. It's performing a very interesting function, right? It's pumping data through the system in response to things that happen. So a ring, the action of a ring, is just an upload to cloud storage. That's all it is. But that effectively kicks off everything else that happens later. Same thing with the Cloud Function on the south side. It's triggering in response to a touch of a button in an app, but it's moving the flow of data back towards the IoT device. And this is how I see IoT devices and apps, and it could be Android or iOS or even web apps, all sort of sharing and moving information around each other. It would be a lot more difficult without Cloud Functions. So there's another part of the UI. There's a recycler view that shows all of the rings. So if you want to see a history of what happened, that's fine. Android developers here? Anyone know recycler view? Do you like recycler view? Is it fun? Okay, one, yes. Okay, so I don't like recycler. I mean, it's a very functional tool, but I don't like writing the code for it. Let's just say it's kind of a pain. This recycler view is super easy to implement with Firestore Recycler Adapter. This is another Firebase UI component. Again, remember, Firebase UI is a collection of tools that make it easy to get data out of Firebase and into your app. So you use Firestore Recycler Adapter, and it's automatically keeping everything in this list up to date. It's making the queries. We're also using Firebase UI to download those images and store or display them with Glide. It's like so few lines of code. It just makes me happy. Now, Firestore Recycler Adapter may not do everything you want it to do, but it does a lot, and it's worth looking into. So what about security here? I haven't mentioned anything at all really about authentication or making sure that your cloud storage is protected or your Firestore is protected. If you want to secure this diagram, basically you're going to have to lock down cloud storage and lock down Firestore. Because the way most people implement it, the way I implemented my project to begin with, the first thing I did is I turned off security on everything. Let's just be honest, it's easy to write code that doesn't depend on security. So this was my Firebase storage rules: allow, read, and write always, right? It doesn't matter who you are, where you are on the internet. You can upload files. You can ring my doorbell. Don't do that. This is bad. Don't ship an app. We find that people do. People cut out security rules altogether, and they ship their app, and then fortunately they're not being hacked because they're not big yet. But if they became big, this would be a problem. Same thing with Firestore. Looks exactly the same. Read and write for everyone. Don't do this. It's a bad idea. So what do you do about security if you're building something on top of Firebase like this? I will acknowledge it's easy to get started without, but you should design ultimately with the idea that you will lock things down. Minimally, you should assume that the user needs to be authenticated. You should be using Firebase Authentication to get an authentication credential, a token from the user that lets you know they are who they say they are. That's the end game here, right? Is to get them logged into the system. Then your rules basically derive from what that user's allowed to read and write within your database. You should also consider data validation rules. They're similar to authentication rules, except you can restrict the actual contents of the data that are being read and written from Firestore and cloud storage. So this is optional, but it's a good idea to keep things locked down and make sure bad data isn't getting into your system. So you can read more about storage rules and Firestore rules. I won't go into that right now. But when it comes time to implement authentication, if you had to do this from scratch, you are in for a nightmare. Authentication login flows are hard. They're like really hard. There's a lot of places to go wrong, a lot of mistakes to be made, and it's boring to do. And you'd rather focus on the functionality of your app, not on implementing some authentication flow. Fortunately, authentication is easy, again, with Firebase UI. So Firebase UI is another component in the Firebase UI collection of libraries that basically will handle all of that for you. You don't write any lines of code to do authentication. All you do is kick off an activity. So here, we'll locate a button in the app somewhere. And when that button is clicked, presumably it's a login button, what we'll do is say, hey, Auth UI, give me an intent to launch that handles the flow that I want. That's all this is saying. So you start activity for result. And Android developers know that if you do that, when the activity that's launched finishes, you'll get a notification later, or not a notification, but you'll get a call to on activity result within your activity. All you do is just check result codes. You will know if the user's logged in based on checking result codes. Like it really is that simple. So presumably the authentication happened, the user got logged in, we have a token, now we can get a hold of that token and do something with it. There's one little interesting line of data there. If you want specifics on how the authentication either passed or failed, it'll parse the intent that comes back and give you some more detailed information. Okay, but the question is that's good for an app that has a UI and a touch screen and like phones and tablets all have that. But how does a thing get logged in, right? I mean, Android thing may not even have a touch screen, right? Well, first of all, the UI providers or auth providers, we delegate to other SDKs. So if you're doing a Twitter login, we'll actually have the Twitter SDK do the login. Same thing with Facebook. Same thing with, GitHub provides. Well, anyway, some of these may not be supported on Android things, right? So you're kind of hamstrung. On top of that, the Android thing may not even have a screen. Like the thing you're actually shipping could be tiny, right? It could be hidden behind something. The user doesn't even know that they're interacting with it. Maybe it just has a button or like an LED display. Like you don't know. You can't authenticate with that. Like how does the user get logged into that? And you don't even want the end user to have to log in to enter your house, right? That's kind of silly. It's like, in order to ring your doorbell, give me your Google auth. Like that's kind of a silly proposition. So we don't want anyone to have to log in. But we need authentication to happen. You could use anonymous login, but that's kind of an abuse of what anonymous login is supposed to do. So with Firebase Authentication, you can do something called anonymous login, and it's a way to get users logged in and have an account without having to prompt them for anything, so it's frictionless to get in. But when the user does eventually want to authenticate, you can upgrade that anonymous account to Facebook or Google or Twitter or whatever. So it's really not the right thing here. It's best to get an actual user credential for a real login that you can use to get this device reading and writing Firebase safely. So the idea here is we need to get the homeowner's credential, get it to the device somehow so the device can read and write Firebase safely. This is the trick. The thing is, how do you do that connection between the app and the IoT device, right? They're not connected to Firebase, right? The thing is not yet connected. It's not authenticated, right? So how do you bypass Firebase in order to get an authentication token over there? Well, the way I did that was with the Nearby API. So Nearby works with both Android and iOS. It's basically ad hoc Bluetooth communications. So there's two different APIs within that. There's Nearby Messages, which is kind of a pub-sub model. So you have one app or thing publishing information as a message, and you have another app receiving that. So it's one-way, tiny message communications. It will select from Wi-Fi, Bluetooth, or Bluetooth Low Energy. Like, it will just figure out whatever's there. So even if the devices aren't connected to the internet, they can still talk to each other. So we're kind of bypassing Firebase altogether. But the problem I found is that this didn't work with Android Things 0.6.1. That's kind of a shame, because this is exactly how I wanted to send that token. It's just a tiny little token. I don't need to do anything complicated. But it turns out there's another Nearby connection API called Nearby Connections. It's peer-to-peer networking, so you're basically kind of opening up an over-the-air socket through Wi-Fi, Bluetooth, or BLE. So it turns out this does work, and I was able to use this to shuttle the token around. So I'm not going to, it's a lot of code actually, and I don't have time to go over it all, but there's a procedure that the apps have to go through. So you imagine you have the doorbell and you have the owner app, and you're in the setup phase and you want to get this IoT device logged in. It needs a token. The owner has already logged in with the app. They just need to get an authentication token from the app into the IoT device. So they're going to check permissions. One is going to start advertising. The other is going to start discovering. When they find each other, they'll connect to each other. Then I'll send a payload of this token over the virtual wire, disconnect. And then the thing can sign in using Google and Firebase Auth APIs. And so the sign-in is actually pretty straightforward. So once we have a token in hand, and a token is just like a string of about 4K in size, we're going to, and it is a Google authentication token. So I'm restricting this to only Google Auth, not Firebase or Twitter or whatever. So this is the case where Google is allowed only. We're going to take that token, ask Google Auth for a credential, grab a hold of that credential, then use that to sign into Firebase. Now, this is just like they signed in normally, right? All we've done is short-circuit the UI auth flow. The UI auth flow happened on the phone. Now we're just going to reuse that token on the device. So now the device is authenticated as the homeowner, which means that now the device can read and write safely with cloud storage in Firestore. OK, so that's the entire system diagram. What we did is we added one more thing right around. We short-circuited all the Firebase components just this one time to get that token transferred. So this is what the total system diagram looks like. So what can be improved here? Well, like it's sort of a hackathon project. I need to clean up the code, right? That's always going to be true. And this did originate as a hackathon project. We have what's called Firebase Hack Weeks, and this is what I built. So it needs some code cleanup. And I do want to open source it. So follow me on Twitter, or if this video gets posted anywhere, I'll make sure that link gets out so you can see exactly how it actually works. It needs a better UI, obviously. This is not a shippable product. But if I did want to ship it, it would need some fairly serious productization. So if you were actually, like me, want to disrupt the doorbell industry, you can't do it in exactly the way that I just proposed. This is good for hobbyists only, right? And it's good for hobbyists because you can't expect a typical customer to go in and create a Firebase project. Everything right now is centralized in that Firebase project. You can't have end users go in and create a Firebase project. You also can't programmatically create a Firebase project. A lot of people want to. It gets asked a lot, but you can't do it. So if you're going to ship this using Firebase, you'd need to create your own one project and set up something for multi-tenancy so all your customers can all be using the same project. And of course, they won't see it. They don't know there's cloud storage. They don't know there's Firestore. They don't care, right? They just want the doorbell to work. So you need a fairly massive restructuring. And also, you can't use FCM topics securely because topics work for all the apps, all in the same project. All can listen to each other's topics. Now, you don't want one person's doorbell notifying the entire world of apps that are hooked up to your one Firebase project. So it just requires a different way of thinking about it. This also needs better security, because right now it's like everyone can notify everyone else, and if you had multiple doorbells, they would all be ringing each other. You know, so it just needs a way to sort of lock down a little bit better what can be read and written. In particular, though, that nearby connection, when I was sending that token around outside Firebase, there is nothing stopping a rogue app from trying to intercept that connection during setup time. So if you're there, you're installing your doorbell, you're going through the setup, you're about to do a nearby connection, there's nothing in the code that I wrote that actually checks to make sure that both sides agree to transfer this token. And your ID token is a fairly sensitive piece of information, right? You don't want rogue parties coming and getting your token, because now they can log in as you and do fairly terrible things in your name. So you'll need some sort of way. It's kind of like Bluetooth pairing, right? If you're pairing something, there's usually a 4-digit PIN, and you agree on both sides, yeah, this is the 4-digit PIN. It can work the same way with nearby connections. You basically have a little auth token. You could display that on like a 14-segment display, and again on the app, and make sure that both sides push a button at the same time to authorize that connection. So it needs to be tighter, and like I said, tighter security rules for both storage and Firestore. So that's all well and good, but what else could we add here? Like, this is a really basic doorbell. It does the basic doorbell function. And it's kind of cool because you can let people into your house without even being home, theoretically, right? As long as all these things are connected to the internet, it doesn't matter. But we can make this better. So I have some ideas for that. You could, if you're using Cloud Functions, you could do facial sentiment detection. So not only can you see the face, but you can also get an indication. If you're face blind, right, you can get an indication like there's an angry person at your house, like maybe we shouldn't let them in. That's kind of goofy, but that just illustrates that you have a lot of things you can do at the Cloud Functions layer that you wouldn't normally want to do inside the app. You could build a voice intercom. So say someone rings the doorbell and you want to talk to them before you let them in, right? Maybe it's a delivery person, or maybe you aren't sure, or maybe for whatever reason you just want a voice intercom. Now this is super easy. The code is basically identical on the IoT device and the Android app because you're just using audio track and audio record to manipulate the audio device. And I actually tried this on my board. It does work. You can do audio recordings. So you can make like a push-to-talk walkie-talkie kind of thing, which would be kind of cool. You could also add speech to text with that if you're using the Google Cloud Speech API. So imagine you did implement this walkie-talkie thing. Someone on the device pushes a button, they say something, that gets uploaded to cloud storage. You write a Cloud Functions trigger to grab that audio, send it to Google Cloud Speech API, get text out of that, then use that to display in the app. So now it's a little more accessible. So if you're in a situation where you can't play out loud, but you want to hear what was said, you could do that as well. You could make digital keys. So imagine you have a guest app. So there's an owner app, like the homeowner's app. You could also produce a guest app that lets people get in through like a one-time token
that you authorize for that app. Or maybe you could make one-time printable QR codes. So someone could hold the QR code up to the camera. The camera could take a picture, scan the code, then determine, is this a key? Is this a valid key? And you can make it like one-time use only, right? You could mark something saying that QR code is in use or has been used, it's been exhausted, no more. So these things would be fairly easy to implement, I think. So you can have a fairly robust, and this is becoming more of like a security, like a digital entry system. It's gone beyond what is just what you would think of normal like doorbell that you would install in your home. So I think there's a lot of possibilities here. That's all I've got. Hope you enjoyed hearing about my project. So we have a little more time. Are any questions? Yeah.
This is the first I've heard about Android things, and I looked it up, and it seems like there's a company called Texion that's selling these, and it feels very much like it's like a third-party thing. Is it?
It is. So Texion actually makes the board that I used to experiment with. So at the beginning, when I showed you that board, they make that. And then there's another company called Pimoroni, which makes the rainbow hat. So yeah, the idea is that Google doesn't necessarily need to be in the business of manufacturing developer boards. Like there are a lot of great hobbyists and like IoT-centric companies that will do this much better than Google ever could. So we'll just partner with them and say, hey, we'll give you copies of Android Things. We'll work with you to refine how Android Things works and is flash devices. And, how do you hook up peripherals? So that's, yeah, it is third party. Like those devices would be third party. The thing is, that device I showed you, that board, you would almost never ship that. That's not a shippable thing. That's for experimentation only. What you would actually ship is, well, what you would produce is a schematic, and that schematic would be built by someone, and then the builder of that schematic would then ship you devices by the hundreds or thousands or however many you want. You would ship those. So you would, as a software guy, I appreciate that very much, right? All I have to do is specify what I want the thing to look like and be like. I don't have to have any hardware building experience. Someone else will do that for me. So that's kind of how Android thinks it's supposed to work. You have a development board. It's kind of like having an emulator, right? You don't actually run your app on an emulator. You build it on an emulator, and then you ship it in the Play Store and run it on phones. So that's the relationship there. Anyone else? All right, cool. Well, if anyone has any more questions, you have more detailed things you want to know about, I actually brought some of my hardware with me. So if you spot me outside or around here and you want to take a look, please feel free to approach me. Thanks.